to standard temperature and pressure. We abbreviate that STP. So what does STP stand for? Standard temperature and pressure. Because here we are, we happen to be here in New Mexico, and so I'm in a room. Okay, the room right now, the temperature might be, I don't know, it might be 70 degrees, might be 68, might be 72. So I do an experiment here. Well, I've got to adjust that so that everybody's experiment's the same. So standard temperature and pressure. It's kind of interesting. The standard temperature is 0 degrees Celsius. Wow, that's at freezing. So I know right away that, yeah, I'm going to have to adjust mine. That's not the standard temperature here. But then whenever I adjust it to freezing, it's the same no matter where I'm at around the world. That's kind of cool. So standard temperature, the value is 0 degrees Celsius. The standard pressure is 1 atm. Now, that's not an automatic money machine, okay? That's 1 atmosphere. So that's the amount of pressure, the amount of air pressure, barometric pressure at 1 atmosphere is at sea level. So I have to adjust once again. So we talk about minute rice. How long does it take to cook minute rice? And we may have mentioned this a little bit before, I don't know, but in New Mexico it takes us a little bit, that minute rice, it's not exactly a minute. If you cook it 1 minute, it's not going to be really all the way done because that 1 minute is at sea level, at 1 atmosphere. And we're here in New Mexico, we're we're about 3,800 feet above sea level. So what happens is we don't have quite the air pressure, so we have to cook ours a little longer. So if you really got to get a life, how long does it take to cook minute rice in New Mexico? It takes 1.12 minutes. So you really got to get a life if you're figuring out your minute rice. But the chemistry aspect of that is that 1 atmosphere is at sea level, and so you have to adjust if you're above or below sea level. Now, we're going to move into the last concept of this video, and this is Avogadro's number. Now, this is an amazing thing, and I can't even explain it even today. But Avogadro, years ago, scientists would come in, and they would come into these symposiums that they would have once every 4 years, and scientists would come in and say, "Oh, I think we need to have this concept, or I see this, or here's something we need to do." And a lot of times these guys were so ahead of their time that people just look at them like, I have no clue what you're talking about. Well, years and years ago, Avogadro came in, and Avogadro's the one that came in and said, we got to have a unit of measure for all these elements. We've started to develop the periodic table, and so Avogadro says, let's call it a mole. Let's call it a mole, okay? So he says, let's say this is a mole of something. So he says, we got to have a certain weight of that. Okay, we got to have a certain amount. So he figured out the number of atoms in 1 mole of any substance was 6.02 times 10 to the 23rd. Now, let me explain a little further what he means by that. Okay, so we take the gram atomic mass number, like hydrogen, is 1.0079 gram units. Okay, and carbon, we'll just round carbon off and say that it's 12 gram units. It's 12 point, we check our periodic table, what is it, 12.04. Okay, so he would say that, okay, so in carbon, he would say, all right, that weighs 12 atomic units, but he figured that how many atoms there are in that was 6.02 times 10 to the 23rd. Now, this just still blows my mind. Let's look at what he's saying here. He's saying that if I have 1 mole of carbon, I have an amount of carbon that's right here that basically weighs 12 grams. He's counting the number of atoms there, and he's saying it's 6.02 times 10 to the 23rd. Well, I wrote that number on the board, okay, 602, okay, and so I wrote 6.02 times 10 to the 23rd. Guys, I don't even know how to name this number. 602 quadrillion, badillion, bazillion. We don't even have a name for this number. But the crazy thing is now we have the technology to actually count atoms. And when we counted 1 mole of carbon, okay, 1 mole of carbon, 12 point whatever gram atomic units, we found out that it had exactly this number of atoms. Wow, that's freaky. And even hydrogen, 1.0079 gram atomic units of hydrogen had exactly this many atoms. So it's fascinating, and I don't know, my theory is he had to be a time traveler, like Back to the Future. I'm sure he learned it. I'm sure he learned it in his college chemistry class and went back in time. I mean, I'm not sure how else a guy would know these things, but it's really kind of freaky how some of these scientists and some of these people years ago figured out things that we still don't understand. But we use Avogadro's number all the time. So in your labs, okay, especially the lab that you have coming up, it will say you'll calculate, and it'll say how many moles, okay, it'll say how many moles do we have it'll say how many moles do we have, and then it'll say how many atoms. Okay, it'll say how many atoms. Well, remember there's 6.02 times 10 to the 23rd, okay, atoms for every mole. Okay, so there's 6.02 times 10 to the 23rd atoms for every mole. So if there was 3 moles of something, 3 moles, and they want to know, and then they ask you how many atoms, what are we going to do? We're going to multiply that times Avogadro's number. So we're going to have this 3 moles times 6.02 times 10 to the 23rd. That's where you need exponents for your calculator to be able to put those on. And that will tell you what? How many atoms there are in that answer. So it's kind of cool. So if you ever see how many atoms, then you multiply it times 6.02 times 10 to the 23rd. And whose number is that? That's Avogadro's number. Okay. So kind of a crazy deal, interesting deal. But once again, anytime we see how many atoms, we refer to Avogadro's number. On your next test, I will ask you, what is Avogadro's number? It's the number of atoms in 1 mole of any substance, and I will ask you for the value of that, and you'll tell me 6.02 times 10 to the 23rd. When you get to a lab coming up that talks about the number of moles and number of atoms, you'll calculate moles, and then it will ask you how many atoms, and you'll multiply it times Avogadro's number. Okay? Pretty full video this time. We'll see you next time.